Okay, so here we have a series. This series is perfect for using the ratio test because it involves factorials, right? And remember, whenever you have a series that involves factorials and you want to test for convergence, best thing to do is to use the ratio test. Okay, now our goal is AC, CC, or D. First thing I need to do is I've got to figure out what are my terms. Because in order to apply the ratio test, I need to have the ratio of consecutive terms. Why did I choose this problem? Because students find this tricky. So I wanted to do an example or two and explicitly show you how to compute the successive terms when your terms are kind of skipping numbers. Like see on the bottom, 2 times 5 times 8, right? So how do you figure out the next term? Okay, so let's get started. So now my first term, or my first attempt is going to be to say that a sub n is equal to n factorial divided by 2 times 5 times 8 times dot dot dot. Now here's the key. The key is to write down not only the last term, which is 3n plus 2, but also to write down the term before it. So what is the term before the last term? What is the penultimate term? Okay, if I stop at 3n plus 2 and I'm jumping by threes, then the term before the last term is going to be 3n minus 1. Okay, do you see that? So here's how to see that. So let's see here. Right, what's the term before 8? Well, I need to subtract 3 and then I'll get 5, right? What's the term before 5? Subtract 3 and then I'll get 2. What is the term before 3n plus 2? Well, I need to subtract 3. And what is 3n plus 2 minus 3? 3n minus 1. Okay, so that's why we have 3n minus 1. And this is going to help because it's going to allow us to make sure that we are canceling terms appropriately. Okay, so this is a sub n. Now, the question is, what is a sub n plus 1? Well, we know everywhere we see an n, replace it with n plus 1. So in the numerator, we'll have n plus 1 factorial. And in the denominator, 2, 5, 8, dot, dot, dot. Instead of 3n minus 1, I need to have 3 times n plus 1 minus 1. Okay, and then instead of 3n plus 2, I need to have 3 times n plus 1 plus 2. Okay, so let me simplify this. So in the numerator, I should have n plus 1 factorial. And in the denominator, 2 times 5 times 8 times dot, dot, dot. Now, what should this be? So this will be 3n plus 3 minus 1. Okay, and then my last term will be 3n plus 3 plus 2. Okay, so let's see here. So we should have n plus 1 factorial over 2 times 5 times 8 times dot, 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 times 3n plus 2 times 3n plus 5. Okay, now let's set up that ratio. What is a sub n plus 1 over a sub n? Okay, I need to take, this is my a sub n plus 1, copy, paste. Okay, so I've got that. And then divided by and then what is my a sub n? It's up here. Let me copy n plus 5. Okay. Also in the denominator, I'll have this n factorial. And in the numerator, I'll have 2 times 5 times 8 times dot, 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 times 3n minus 1 times 3n plus 2. So all I've done is just rearrange, rearrange using algebra. So that's all we've done. Now it's time for the fun part, which is to cancel stuff out. Now, n factorial over n plus 1 factorial over n factorial is just the same as n plus 1. Right? Did we get that from before? n plus 1 factorial is equal to n factorial times n plus 1. Remember? So that means that if you have n plus 1 factorial over n factorial, that's just going to be n plus 1, right? Because we can just divide both sides by n factorial. Does that make sense? Okay, so let's see. So I'm going to erase this actually, and just to clean things up. So I'll have n plus 1 here in my numerator. And now what about canceling things out in the denominator? Do you notice that all of these terms show up here? Right, 2 times 5 times 8 times ... times 3n plus 2. They all cancel, so they're going to cancel each other out, right? And what I'm left with is just 3n plus 5 in the denominator. So we'll have 3n plus 5 in the denominator. So what does that mean for my L? L is equal to the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So that's going to be the limit as n goes to infinity of the absolute value of n plus 1 over 3n plus 5. What is this? You got a couple of different ways you can approach it. The first thing is we can eliminate the absolute value signs because n is a positive number. So n plus 1 is going to be positive, 3n plus 5 is going to be positive. So we'll just have n plus 1 over 3n plus 5. We don't need the absolute values. Now, at this point, you can use L'Hopital's rule. You can divide everything, right? Divide everything by n. Divide by n. Divide by n. So that you would get n over n plus 1 over n divided by 3n over n plus 5 over n, right? Equals, and so then that's just going to be 1. So this is going to be 1. This is going to be 3. That's going to go to 0. That's going to go to 0. So this limit is equal to 1/3. Also, what I want to point out is that on an exam, if you look at n plus 1 over 3n plus 5, and you say, oh, this is equal to 1/3, you do not have to show work to justify that, okay? It's only if you prefer to show work, you can. If you like to use L'Hopital's rule, go for it, right? But if you can look at that and tell that it goes to 1/3, you know, that's totally fine. So L is equal to 1/3, right? So since L is equal to 1/3, our series is absolutely convergent. So our series is going to be absolutely convergent because L is 1/3. That's it.